This video is on 45, 45, 90 special right triangles. I'm going to be doing a few examples. We're going to be using this equation. The hypotenuse is equal to your leg times the square root of 2. This is the equation you want to know for 45, 45, 90 triangles. In a previous video, I mentioned that you can still solve these triangles using Pythagorean theorem, but special right triangles will make it a little bit easier and a little bit quicker if you know the equations. So we're going to continue using this equation. The hypotenuse is equal to your leg times the square root of 2. Practice is we're going to find the value of the variables, so we have to make sure we know which variables are in here. On problem 1, we have a right triangle, and it is an isosceles right triangle. Therefore, the angles are congruent, so it has to be a 45, 45 degree, 45, 45, 90 triangle. So since this is a 45, 45, 90 triangle, we automatically have variable z. This would be 45 degrees right here. Now to solve for the x and the y, since your legs have to be the same, they're congruent to each other, we know that our x value must be 3. To solve for the y, which is your hypotenuse, we're going to use this equation. Hypotenuse is equal to leg times square root of 2. The hypotenuse is y. Our leg is 3 times the square root of 2. Because what we did is the hypotenuse is equal to your leg times the square root of 2. We're just plugging it into the equation. Now, y is by itself, so 3 times square root of 2 is 3 square root of 2. So we can find all of our variables. X is equal to 3, y is equal to 3 square root of 2, and z was equal to that 45 degrees. Those are the 3 variables. On question 2, we have a right triangle, and we have 2 congruent angles. If these angles are congruent, then those angles must be 45 degrees. So 45 degrees. So if those 2 angles are congruent, then we know that our 2 sides also have to be congruent, because that's the isosceles triangle theorem. This is actually the converse of isosceles triangle theorem. So now we can find, if we have one leg, we have the other leg. These have to be the same. So we know that x is going to be 3 square root of 2. Now to solve for y, y is your hypotenuse. So we're going to plug it into the equation that your hypotenuse is equal to your leg times the square root of 2. Well, our hypotenuse is y. Our leg is 3 square root of 2. And we're going to multiply it by the square root of 2. Now, even though the leg has a square root of 2 in it, you still have to multiply by the square root of 2. You plug it in as it's written. So now we have 3 times, the square root of 2 times the square root of 2 is the square root of 4, which is just 2. So it's really 3 times 2. So now we have our values. So our x value, I'm just going to write it off. X is equal to 3 square root of 2, and y is equal to 6. Because 3 times 2 is 6. On this next problem, we have a right triangle. We have a 45 degree here. That means in order for this to be a triangle, this is 45, then we also have to have 45 in this corner as well. So if we have congruent angles, 2 congruent angles, the converse of isosceles triangle theorem says that these 2 sides are also congruent. And we want to solve for x and y. Now in this case, we have the hypotenuse. So again, our equation is hypotenuse is equal to your leg times the square root of 2. Our hypotenuse in this case is 8 equals. Our leg is either x or y. You could pick either one. So I'm just going to go with x times the square root of 2. Now I want to solve for x by dividing by the square root of 2. So if I divide this by the square root of 2, I'll have x is equal to 8 divided by the square root of 2. However, you cannot leave a radical in the denominator. This is when we have to rationalize the denominator. This is when we have to rationalize. So in order to rationalize this, we have to multiply by the square root of 2 to the top and bottom because we want to get rid of the irrational number in the denominator, and we are technically multiplying by 1, which is why we're allowed to do this. So this becomes 8 times square root of 2 is 8 square root of 2 over square root of 2 times square root of 2 is just 2, and then we can simplify this. So our values, our x value is equal to 4 square root of 2. And since x and y are the same, we know that y is also equal to 4 square root of 2. These are our two solutions. You just have to remember to rationalize. On this next problem, number 4, we have two congruent sides. So therefore, this is a 45, 45, 90 triangle. So we can use the equation that the hypotenuse is equal to your leg times the square root of 2. And we look at our problem. We do have the hypotenuse, which is 8 square root of 2. 8 square root of 2 is equal to your leg, again, could be either one x or y, so I'm just going to pick x again, times the square root of 2. Now in this case, there are two things you could do. You could solve for x by dividing by the square root of 2, or you can recognize that since they both have the square root of 2 on it, the question is asking what value of x would make the right-hand side be the exact same as the left-hand side. The only value of x that can make them be the same is 8. But you can simplify this by dividing by the square root of 2. In this case, you do not have to rationalize because the square root of 2 and the square root of 2 will divide to 1 for both parts. So again, x is in fact equal to 8. So if x is 8, y also must be 8 because this is an isosceles triangle. So again, if you recognize that you have the exact same value on the left as the right, and it's just looking for that one part, what is that value of x that would make the entire left and the entire right be the same? That's really what you're doing when you're solving an equation. Example 5, again we have two congruent angles in a right triangle, so these must be 45 degrees. Therefore, we have two congruent sides. This is the converse of isosceles triangle theorem. Since this is the 45, 45, 90 triangle, an isosceles right triangle, we can use the equation the hypotenuse is equal to your leg times the square root of 2. Our hypotenuse in this case is 6, is equal to our leg in this case, again, could be x or y, because they're both the same. I'll just use x times the square root of 2. Now, because this does not have a square root of 2 on it already, we do want to divide by the square root of 2. We'll divide by the square root of 2. So x is equal to 6 divided by the square root of 2. But again, we cannot leave a radical in the denominator, and there's nothing it can simplify with in the numerator, so we do need to rationalize on this one. So this is a rationalizing problem. I'm going to write it off to the side. Rationalize. So in order to rationalize, I'm going to multiply the top and the bottom by the square root of 2. And I will get 6 times square root of 2 is 6 square root of 2 over square root of 2 times square root of 2 is just 2. And I will want to simplify this because 6 divided by 2 can simplify. We'll end up getting x is equal to 3 square root of 2. So if x is 3 square root of 2, so is y. So y is equal to 3 square root of 2. On this last problem, number 6, we have a 90-degree triangle and a 45-degree in here, so this means that this is also 45 degrees. So since I have 45, 45, 90, I know that my two sides are going to be the same. My two legs are the same. That means I automatically will have the value of y, because it's already the same. It's going to be 5 square root of 2. Now I want to solve for x, which is your hypotenuse. Because 45, 45, 90, you can use the hypotenuse is equal to your leg times the square root of 2. The hypotenuse in this case is x, is equal to our leg is 5 square root of 2. times, we're going to multiply by the square root of 2 again. So this becomes 5 times, square root of 2 times square root of 2 is 2. So we end up getting just 10. So in this case, x is equal to 10, and y is equal to 5 square root of 2. So each time when you have a 45, 45, 90 triangle, you use the equation that the hypotenuse is equal to your leg times the square root of 2. And you could have solved each of these problems by using the Pythagorean theorem because your x and your y would be the same. So I could just use x squared plus x squared is equal to 8 squared. And then I could have solved and simplified my radicals, and I would have gotten 4 square root of 2.